Hello viewers, welcome once again to Quest, your favorite weekly inter-school science quiz which gives you a behind-the-scenes look at how many things work. Conducting a whole lot of new experiments for us once again is Mr. G.S. Rautela, the Director of Nehru Science Centre, Mumbai. Let's give him a warm welcome. Hello, sir. Mr. Rautela, welcome back to Kolkata.
Thank you very much.
How's the weather in Bombay?
Oh, it's very sultry, humid.
Well, let's see if you can make a change to our scenario here in Calcutta.
Yeah, the monsoon is going to make it.
Yes, okay. We have two new schools here for you today. On the 𝐺𝐶 team, on my right is Patha Bhavan, and you are?
I'm Abhimanyu Kaur.
I'm Shomu Moitro.
I'm Sangyukta Ganguly.
Welcome to our show. And on my left, the C.V. Raman team are the girls from the National High School for Girls, and they are?
Hello, it's me, Nirupama here. Hi, I'm Kripa Nagarajan. Hello, I'm Indu Pandey.
The rules of the contest, pretty much the same as every week. We have 7 questions in all. The first 4 of them are direct. That's 2 each for each team. 20 points if you get it correct on a direct question, and 10 on passes. If neither team answers, we go into the audience. And more about the buzzer round when we come to them. So the very first experiment today is for the team on my right, that is the 𝐺𝐶 team. So 𝐺𝐶 team, that's the students from Patha Bhavan. The first question will come to you. Do remember, 15 seconds to answer once you've been asked the question. At the end of the same, if you've not answered, it will go over to your adversary team, that is the C.V. Raman team. And C.V. Raman team, we won't give you very much time. Either you have the answer or you don't. Right? Now both teams, please remember, good quizzing is good teamwork. Talk to each other, discuss with each other. And here we go.
Your question is, I have a ping pong ball or table tennis ball, a funnel. I put this ping pong ball under the funnel and blow. Let's see what happens. When I blow it, instead of going away, it rises up. Could you tell me what is the reason?
So, when you blow, air is flowing inside the funnel.
Yeah.
Now, flowing air has reduced pressure.
Yeah.
So, sorry, I'm wrong. When you blow, air gets reflected at the surface and pushes it upward.
No, that's not quite correct. Would you like to try?
Yes, when you pass air through it, the moving air has lesser pressure than standing air, because of which the air which is on the top of the ball is does not exert as much pressure as the air on the bottom, so it rises up.
You are closer to the answer, so I would give you 10 points. You are right in the beginning, but you change your answer. Okay, the correct answer I would like to give you is when you are blowing from here, what happens, there is a low pressure because of the speed of the air is more. Low pressure is a partial vacuum, and the ball tries to come up to the partial vacuum area. That's the only thing, because very light ball, it can rise up. And that's called Bernoulli's principle, as probably you know it.
Well, Abhimanyu, you had the right start to an answer. I don't know why you changed your answer. And well done then, Kripa. That was the right answer. You get 10 points. Let's give a big hand. Mr. Rautela, Bernoulli's principle.
Yeah.
Is this more or less the same principle by which even aircraft are able to lift off?
Exactly. This is what happens on the top of the aeroplane when it tries to fly. There's low pressure, so it rises up. That's again is due to Bernoulli's principle.
Okay.
So air is thrown faster on the top of the aeroplane than at the bottom.
Right. C.V. Raman team picking up 10 bonus points. The next question will come for them, which is their direct question for 20 points. C.V. Raman team then, lucky to get those 10 points after the 𝐺𝐶 team scored a self-goal. Next question is for you, but before that, Mr. Rautela, I believe we need a volunteer.
Yes, I need a volunteer to do this experiment.
All right. Do we have any volunteers in the audience? Yes, why don't you come up? Does he need a mic or?
No.
What's your name?
My name is Indranil Goswami and I am from Patha Bhavan school.
Okay, Nandit, just come behind this.
Yeah. Come this side, please. I request to hold this funnel on the top here. Okay. Little this side. What I am doing is I am pouring water in the funnel what he is holding, and it nicely comes from here. Okay. That's not the question. Very easy. Now what I do is I coil this tube around this. Okay. I think I'll do it myself. Now when I'm coiling this tube, let's see what happens. No water comes. Though the funnel is full of water, the water doesn't come out. The question for the team is, why does not the water come in this case?
Five seconds.
Flowing water always has a tendency to come down, but here since it's rolled on that particular thing, it needs to take pressure to go up and down, which is not provided to it right here. So I mean near the curves, but it has to rise up. It cannot rise up since it has a tendency to go downwards.
That's not very accurate answer. Would you like to try?
Yes, surely, sir. So when you have rolled that pipe over there, first the funnel is getting filled. When the funnel is getting filled, then the corresponding next tube, which is just rolled upward, that part of the tube is getting filled, and the next part of the tube was empty. Because you see the distance up to which the water has raised in the next tube is equal to the height of the water inside the funnel. If there is some kind of difference in the height, then there is a pressure gradient. In that way, the water will flow from the to the next tube. I mean, more water will come from the funnel to continue going to the next tubes, but since there is no difference in height between the next part of the tube and that of the funnel, the water just stays over there due to a lack of pressure gradient.
No, I don't. I'm afraid I won't be able to give you points. There is a very simple answer to this.
Mr. Rotela, don't you think we should go to the audience?
Yes.
Yes, any takers in
Anybody
the
would
audience?
like to try?
You know, maybe you? No? Anyone in the audience? No takers in the audience. Yes, sir.
So I have to explain to you this. When I am pouring water from this funnel, in this case, the water enters in the first tube, then tries to enter in the second tube to the same level what is in the first tube. It equalizes. But between the first tube and the second loop, I mean to say the second loop, there is an air cavity. That air cavity tries to stop water flowing from further onwards. So that's the only catch here, which I would you didn't guess. So otherwise, the principle which you are trying to explain, it has nothing to do with this.
Well then, no score to either team, and we move on to the next question. JC Bose team yet to open their account, CV Raman team on 10 points. Next question for you, JC Bose. Here we go.
You see here we have a setup, one a straight path and one curved path. This curved path is an arc of a circle. Okay. When I drop two balls from here simultaneously, what is going to happen? Which ball will reach the end first? And this arc is longer than the straight path.
So please repeat the question.
The question is, we have two tracks for two balls. One is the straight track, another is an arc. The arc is part of a circle, you can say. Now if I drop two balls from here simultaneously, which ball is going to reach the end and why?
Both will
Which ball will reach
First to the end and why?
Yes, horizontal displacement and this vertical displacement is also same. So
gravitation force दोनों में equal होता है क्या?
okay, sir. So both will reach the. Both the balls which reach the lower part of that setup at the same time, because the horizontal displacement and the vertical displacement in both the cases will be the same.
Okay, would you, do you have any other answer, or you agree with them?
Yes.
Let's do the experiment. This, the arch one reaches first, we have seen this. Much faster than that.
So what is it, Mr. Rotela?
Would you like to try? Anybody in the audience to give the answer for this? Why does it happen?
Can we
I
try
can
just
say.
informally?
Okay.
Sir,
Okay, so in the curved path, the velocity is directed towards the gradient of that point, and that gradient is much steeper than that of the inclined plane.
not always. Gradient is changing, but the velocity is nearly constant, because when the velocity is low, acceleration is more, because the curve is nearly vertical, and it acquires, when it acquires a high velocity, then it becomes nearly horizontal. But now it has acquired a higher velocity, and the straight inclined path, in that path there is a constant acceleration. Now as the curved path is a parabolic path, actually
Circular path.
no
It's not parabolic. Anyway,
parabolic path, so the ball reaches earlier.
no. Anyway, it's not parabolic. This is called cycloid. You know an arc of a circle. Cycloid is the locus of a point on a moving circle, right? That's called cycloid. So in two situation when endpoints are same, the shortest time path is always a cycloid. If you equate it, calculate this, you will find the cycloid is the shortest time taking path between 2 points, okay, irrespective of what is the curve of the cycloid. Okay? So this is what exactly was happening here. So nobody gets a point for this.
No score then to either team. Scores remain exactly where they were. That's JC Bose yet to score, CV Raman on 10. Next question is for the CV Raman team. So CV Raman team, if you're ready, let's see if you can consolidate on that lead. Next question is for you.
I have a straw which I have cut like a flute here. I'm going to toot. When I cut it,
Open it pipe, close and open it pipe.
how wide does the sound change?
Yes, just relax.
Actually, when it is a phenomenon of open end pipe. Here, actually, when we blow, when it is a longer pipe, when we blow it, it gives sound. But when we cut it, the length it decreases, because of which the antinode and node formation is altered. So the sound is also altered.
Now what does change? What changes?
The wavelength.
Would you like to try?
Yes. This is like an open-end pipe.
Yeah.
Now it has a standing air column.
Yes.
Now the fundamental wavelength of the sound is half of the fundamental wavelength of the sound is the length of the pipe. Now if you cut it, the fundamental wavelength, the length is shortened, the fundamental wavelength decreases, and we have a sharper sound.
The pitch increases. In fact.
And what changes exactly?
So as the wavelength decreases, the pitch of the sound increases, and thus
frequency.
we get a more sharper sound.
Can you tell me what happens to frequency?
Frequency is connected by the equation
Increases.
Lambda is
equals to
reducing. The frequency will?
Yes.
As pitch is directly
Inversely
proportional to
So frequency is going
Yes.
to
increase.
And frequency
That's
is
true.
inversely
So
proportional
the
to the
frequency is changing as I have shortened the pipe because of the wavelength reducing. Right? Okay? So that's the correct answer. So they get 10 bonus points.
Well done. So Abhimanyu and Shomo, next time you see a flute concert by Pandit Hari Prasad Chaurasia, you will see him reducing, because he's opening those with his fingers, with those openings, he's reducing that length of the column every time, which is what changes the pitch.
That's true.
Both teams then tied on the same score. At the end of the direct rounds, the next question will be on the buzzer. More about it when we come back. Well, in what's turning out to be quite a low-scoring quiz, both teams are tied at 10 points each. Let's see what they do now. We are now into our buzzer rounds. The next 3 questions are on the buzzer. Remember, teams? If you press that buzzer, you've got to have a question or the answer ready with you, because we will not be asking you the question after that. It's +20 if you get it right, and it's -10 if you do not get it right. These questions will not pass to the other team, they go straight into the audience. Both teams, all the best.
The next question is with the instant stick, that dhoop or agarbatti you call it. This is a little wider one. I am burning this. Now look at the smoke. After some time it starts swirling. You can observe it. It's straight, then it swirls around. The question is, why does it happen? Why it doesn't go straight?
JC Boasting.
So first the smoke comes out straightways, and then it gets diffused into the air, so it swirls out. And another reason is, as the lower part is heated up, so the air from the outside, air which first rises up and tries to go to the cooler parts, so it just diffuses on the cooler parts and forms a swirling motion.
The smoke is hot. First it rises with a great velocity. It is a streamline motion. Now when the smoke diffuses, it is turbulent motion, so it swirls.
Well, I think you have given just the reverse answer to it.
Audience, anyone?
Give me a better answer.
No one. Mr. Rotella, I guess you got to do the honors.
Well, when the smoke is heated up, it rises slowly, not at fast as he said. Okay, because it is meeting the denser air above it. It moves slow, and the motion is laminar. I mean, that is streamline motion. Laminar, so you see it straight. As soon as it goes up, so its temperature falls down because the surrounding, there is a convection of the air from around, and as a result there is a gradient, and there is a buoyancy developed for the smoke because it's lighter, so it moves much faster, and as a result it gets a turbulent motion, and that's where it starts swirling around. So nobody gets a point, rather they get -10 points for this.
JC Bose team, Patha Bhavan, swirling around with your answer in the wrong direction. You move down to naught. That's no score. Girls, I guess you were more judicious in the end by not going for the buzzer and remaining on +10. Next question, again on the buzzer. Welcome back. You're watching the weekly inter-school science quiz, which is brought to you by the National Council of Science Museums and Doordarshan Kendra, Kolkata. Yes, that's right. This is an educational quiz, not so much aimed as a competition as education, and it's aimed at students studying between classes 9 and 12. Scores at this stage: the JC Bose team have to reopen their account because they had some points on the board which are now being taken away from them, and CV Raman team sitting pretty with their 10 points. Next one, again on the buzzer.
Next question is, I have 3 holes on this box, and I can block the square hole with a cube, cylindrical with a cylinder, circular hole, and with a triangular lamina, the triangular hole. Now the question to you is, which block or what shape of block will block all the 3 holes?
Rhombus.
I have 4 pieces here.
Is it from
Which will block all the 3 holes?
The red block.
The red block.
Yes, sir.
Why do you think so?
So at the base it's circular, I think,
Yes, so it blocks the circular hole.
and we just rotate it up to 90 degree,
Yeah.
and then it becomes a square, 2-dimensionally seen from the top.
Okay.
And if we just again take it up and then place it right over here,
They are
the
right.
triangle.
So they get 20 points for this. Let's give them a big hand. Can you tell me what is this called?
Something like, no.
Well, there is no name given to this. Is a projective geometry. If you look at, there's a lamina having three projections as triangular and square and circular is the only piece which comes in that form. This way it's a circular, this way is a square, and this way is a triangle. Okay, that will fit in all the three blocks. So that's the correct answer.
Mr. Rautela, does this shape have a name, or is it just a googly that
No,
you made up?
it's not a name,
Yes.
but one has to imagine what would be the shape. It's a cut section of a cylinder.
I see. Well, anyway, well done, 𝐺𝐶 team. You are now on 20 points. Girls, you're still on 10 as we go into what's going to be the last question of today's episode of Quest. Welcome back. You're watching Quest. And now, the final question. Anything can happen. Over to Mr. Rautela.
Well, I have some powder in this beaker. I add some water, and you see me adding water to this. See what happens to this after some time. I'm trying to pour water back so it comes out. After a few minutes, let's see what happens to this. Now the question is, why does this water get absorbed in the solution, in the powder?
That powder is deliquescent in nature, and that's why it absorbs water.
Can you tell me what is the name of the powder?
It's some magnesium chloride or calcium chloride.
No, that's the wrong answer. Would you like to try? Anyone in the audience?
But tell me the basic concept behind what Shomo said, was that the right concept? Even if
No,
we didn't get the name right?
The powder is porous in nature. It takes the water inside.
No. That's
Anyone
not.
in the audience?
You could have got a clue from me. There is a diaper here.
पानी सोख हो जाता है.
Okay, I would like to give you the answer. If you
Yes,
would like
please,
to
please,
know,
please, absolutely.
the diapers, there is a porous cellulose here which urine goes in, and that gets absorbed by sodium polyacrylate. It's a polymer, sodium polyacrylate. It has loose sodium ions which get removed from this or separated when water is added. As a result, carboxyl ions, which are negatively charged, repel each other, and the chain breaks of the polymer. And when it breaks, the water is taken in. And because its molecular weight is very high, it cannot take so much of weight, it cannot dissolve, so it forms a jelly. And the water becomes a jelly. That's why the urine is soaked in the diapers. So it's sodium polyacrylate. It's made from acrylic acid, you know, C2H3COOH. That is acrylic acid. When you add sodium to that, it makes sodium acrylate. And it's a polymer. Okay, that polymer is such a good compound, has such a good use. It can up to 800 times it can absorb water from its own weight. 1 gram can absorb 800 grams of water. Such a good quality.
Well,
I should show a little later.
I'm sorry, 𝐺𝐶 team. You lose 10 points once again by going for that buzzer. And we finish today's episode with the scores tied. That's 10 points each. With that, we've come to the end of what's been a very topsy-turvy battle where the 𝐺𝐶 team first did, then undid themselves. To twice in succession. Anyway, here's a small memento for them. Give them a big hand. JC team, that's the team from Patha Bhavan, Abhimanyu, Shomo, and Sanjukta. Thank you for coming on our show. And girls from National High School for Girls. That's Nirupama, Kripa, and Indu. Closing scores 10 points to both teams. We hope you enjoyed our show. Please do write in to us with your comments. Our address, West, 𝐶𝐤𝐢𝐨𝐧-𝐬𝐭𝐫𝐚𝐭, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week with a fresh set of faces, 2 new schools. Till then, it's goodbye from all of us here at Doorbrush.